Today we're going to be looking at point slope form. That is page 80. So 2 pages we are adding in. Okay, title page on the left and then your other examples on the right. So point slope form is the final way that we are going to look at graphing linear equations. Point slope form is the least likely that we would use to actually graph in, but it's the most likely we use for other things. Okay, so it's really important that we understand point slope form. There are 2 things that we get from point slope form. We get a point and we get a slope. Okay, the M is still the slope, so that hasn't changed. The point is what takes a little bit more work. The point is going to be our x sub 1, comma, our y sub 1. So even though the x sub 1 comes last, it's first in our point, but it's good because it's next to the x. So our x coordinate is with the x, our y coordinate is with the y. However, we do have to keep in mind that this formula involves subtraction signs. And that changes it a little bit when we're pulling a number out. In fact, we are going to have to take the opposite sign of it, because the negative in the formula makes a positive look like a negative and a negative look like a positive. So if we're given y minus 6 equals 3 times x plus 7, our slope is the easy one to find because it's what's sitting in front of the parentheses. So if we look at this in front of the parentheses, we see the number 3. So our slope is going to be 3. Okay, our point is going to be the x value, so the number sitting with the x, but we need it to be the opposite sign. So this looks like a positive 7, but we need to write it down as a negative 7. Okay, and this looks like a negative 6 for our y value, right? Our y sub 1, it's sitting with a y, but because it looks negative, we are going to write it down as a positive. And again, that's because this sign right here is part of the subtraction, okay, that we see in the formula, not part of the number. So when we look at our second one down here, y plus 12 equals negative 5/4 times x plus 9. Our m is sitting in front of the parentheses, so that's negative 5/4. Our x value is with the x, but it looks like a positive 9, so we're going to write it down as a negative 9. Our 12 looks like a positive 12, but we are going to write it down as a negative 12. Okay, so being able to identify that point and that slope is key to then being able to graph. So it has a similar feel to graphing in slope-intercept form. The first thing that we are going to do is we are going to identify the important information. So we're going to identify the point and the slope. So if we look at y minus 3 equals 2 times x plus 5. Our slope's what's sitting in front of the parentheses, so our slope is 2. Our point, right, is an ordered pair where our x value goes first. So this looks like a positive 5. So we're going to write it down as a negative 5. Our y value is with our y. It looks like a negative 3. We're going to write it down as a positive 3. The next thing that we're going to do is plot the ordered pair. So we're going to take this point that we're given and we're going to plot it. Now remember, don't get confused. Slope is rise over run. So slope is vertical with horizontal. Plotting an ordered pair is still x is left, negative 5, up 3. So here's our point, negative 5, 3. Okay, we are then going to use our slope to find our rise over our run, which is what we did in slope-intercept form. So 2 is not a fraction, so we are going to write that as 2 over 1. So from this point, we're going to go up 2 over 1, up 2 over 1. Okay, we're making that nice long line that goes all the way across our coordinate plane. That has arrows on both ends because we know it represents all of the x and y values that make that true. So let's look at a few more of these. So let's say we have y plus 4 equals 1/3 times x minus 2. Our m is going to equal 1/3. Okay, our point, it looks like a negative, it's a positive. Our 4 looks like a positive, so it's a negative. So we're going to plot 2, negative 4. And from this point, we are going up 1 over 3. Up 1 over 3. So here is our line. All the way across, arrows on the end. Okay, and our next one, so M, the number sitting in front of the parentheses, right, that's really a negative 1. So our M is going to be negative 1. Our point, X is first, so positive 7, positive 5. So I'm going to plot the point 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 7, 5. Now my slope is negative 1, so that is a fraction will be negative 1 over 1. So down 1, right 1, down 1, right 1. Again, if you run out of space, remember you can always bring this line up the other way to get your points on there too. Number 6. So first we're identifying a point in our slope. Okay, so our M, our slope is going to be negative 5 over 2. Now we've talked about this, right? When that negative's out in front, it cannot go with both of them. So we've all been sort of preferring to pull that negative into the top. Our ordered pairs, so our X comma Y. Positive 2, negative 1. So I'm plotting the ordered pair positive 2, negative 1. And now I'm going to do a slope of down 5, right, because it's negative. So down 5. But the 2 is positive, so I'm still going right. But now if I go to count again, right, I can't fit that next one. So just like I was saying on that last problem, you might have to extend this the other way, right? And think about it as if the negative was in the other location. So now I'm going up 5, left 2. And here's my line all the way across the coordinate plane. And then for our last problem, right, our M is going to be 7. Our ordered pair will be negative 1, negative 9. So negative 1, negative 9. We're going to make our slope a fraction, so we're going up 7 over 1. Up 7 over 1. And there is our line.